Okay, now this is a problem related to function. The question is the function f and g are defined by fx is x plus 1 upon x for x greater than 0 and gx as ax plus 1 for x belonging to real number. You have to find an expression for g of fx. So g of fx. So let me first write what is gx. So gx is ax plus 1. Now if I say that g of fx, then it is a of fx, x will replace by fx plus 1. Now a fx, you will say that it is x plus 1 upon x plus 1. So this is our expression for g of fx. Now the next part of the problem. Next part of the problem is, this is our expression. Given that gf2, okay, so gf2, if I see what is gf2, gf2 will be a times x is replaced by 2, so 2 plus 1 divided by 2 plus 1. This is your f, g of f2. Hello, yes, डिप्लोमा क्लास अगर किसी को चाहिए तो प्रोवाइड करते हैं मैम. किसके लिए चाहिए? अच्छा, आप टीचर हैं, आप टीचर. अच्छा. हम्म, ओके, वंडरफुल. हम्म, अच्छा. राइट. नहीं मैडम, मेरे पास अभी ऐसे तो अवेलेबल नहीं है क्योंकि मैं क्लासेस पहले रन करता था, वो बंद कर दिया. मेरे पुराने स्टूडेंट्स कभी मुझे, हाँ, हाँ, कभी वो कॉल करते हैं तो उनके रेफरेंस में कोई बच्चे होते हैं जिनको रिक्वायरमेंट होती है तो मैं प्रोवाइड करता हूँ. अगर कुछ आएगा तो मैं आपको बता दूंगा, अभी तो फिलहाल नहीं है. ठीक है. मैं, देखिए अभी चांसेस बहुत कम है, मैं सेव क्या करूँ आपका नंबर. हाँ. ओके, सो हियर, आई एम सॉरी. Now you understood that what I done, right? Okay. So 5 to the 2. So here the value of A, we get 4. 5 to the 10 and 2 to the 4. So for the B part I get value as 4. Okay. Now let us move to the next part of the question. Next part of the question is that given that the graph y is equals to fx has the minimum point when x is equals to 1, explain whether or not f has an inverse. Okay, so what is our fx? Now if you see fx, okay, now fx, if I see, it is x plus 1 upon x for x greater than 0. Okay, I will write it, y is equals to fx, which is x plus 1 divided by x for x greater than 0. Okay, now the question is, given that graph y is equals to fx has the minimum point when x is equals to 1. When x is equals to 1, what I will get? 1 plus 1, I will get 2. Okay, explain whether or not f has an inverse. Now I have to check whether this f has an inverse or not. Now if you see the domain of the function, domain of the function is what? Domain of the function is all positive real numbers, right? X greater than 0, and the range which is x plus 1 upon x. which is x plus 1 upon x. Now when the graph has the minimum point when x is equals to 1, and that minimum point what we are getting 1 plus 1 upon 1, which is 1 plus 1 2. That means your y is more than 2. Okay, your y is more than 2, whereas so domain and range both are not same here, right? As domain and range are not same, so f inverse is difficult, right? I will say that it is not 1 1. So is this function 1 1? Okay, so as what I say that y minimum is what? It is 2. So for x is equals to 1, I have value 2, and all y values are more than 2 only. So it is not 1 1. There are some point in x for which I have no image in y. So I will say that fx has no inverse. Fx has no inverse. Now for a function to be inverse, it should satisfy two conditions, that it should be 1 1 and it should be onto function. Now here it is not onto function. Now let me check if it is 1 1. Okay, let us try by that also. So what we do, we will consider fx1 is equals to fx2. Now if I consider fx1 is equals to fx2, I have x1 plus 1 upon x1 is equals to x2 plus 1 upon x2. So therefore here I have x1 square plus 1 divided by x1 is equals to x2 square plus 1 upon x2. So therefore I have x1 square x2 plus x2 is equals to x1 into x2 square plus x1. Now if I bring everything on one side, I have x1 x2, I can take common this x1 x2, and in bracket I have x1 minus x2 plus, or I will say that minus, here I have x1 minus x2 is equals to 0. So here I have x1 x2 minus 1 and x1 minus x2 is 0. So either x1 x2 is equals to 1 or x1 is equals to x2. Now if x1 x2 is 1, then also I have f of x1 is equals to f of x2. So therefore here fx is not 1 1. Here fx is not 1 1, and therefore f inverse x is not possible over here. Now it is given that a is equals to 5. Find the simplified expression for g inverse fx. So g inverse fx, first gx, let us see what is gx. Now gx, if I see, gx is ax plus 1 and a value is given 5, so 5x plus 1. So gx is what? Gx is 5x plus 1. G of fx will be 5 times. Now x will replace by fx, which is x plus 1 upon x plus 1. I have to find g inverse of fx. Or simply here, okay, instead of writing this, I will say that g of fx is 5 times fx plus 1. Now we know that if we have y is equals to fx, then x is considered as f inverse of y, right? Then x is considered as f inverse y. So g of fx, now this fx, if I say y, so I have g of y is equals to 5y plus 1. So what I will do, g of y, I will express this y in terms of this g of y. So this y can be written as g of y minus 1 whole divided by 5. Okay, so this y is nothing but it is g inverse. Okay, so therefore I will say that therefore g inverse of fx is equals to g inverse of fx. Now this seems to be very complicated. So g inverse of fx is g of y is g of fx. Y is fx only, so y is nothing but g inverse of fx. So this is equals to there should be some better way of explaining all these things. Okay, let me remove this part, right? G inverse fx. So again I will start, I will say that g of x is 5x plus 1, right? So therefore I will say that x is equals to what? That is gx minus 1 divided by 5, and therefore I will say that g inverse of x is equals to g inverse of x is equals to x minus 1 divided by 5. Okay, so g inverse of x we get x minus 1 whole divided by 5. Therefore if the expression is g inverse of fx, so simply I say that this is fx minus 1 divided by 5. Okay, so this f of x is what it is, x plus 1 upon x minus 1 whole divided by 5. Now if I want, I can explore this, and so this is equals to, we can simplify this further, and it will be g inverse of fx will be x square plus 1 minus x whole divided by 5 times x. This is G inverse of x. Explain why the composite function fg cannot be formed. Now fg, gf hello. हाँ है ना, बताओ। मैंने ऐसा नहीं बोला था, मैंने बोला था वहाँ कुछ चेक करना है, बोल रहा तो ठीक है, नहीं होगा क्यों लक्ष्य ने फोन किया था इसके पापा ने कहा था। अच्छा हाँ हाँ हाँ, तो अभी कहाँ हो? अभी जस्ट आगे पहुँचे हो? 1 बजे छूटेगा ना फिर? हाँ तो उसको फोन फोन करना, अभी छूटेगा तो फिर कॉल करना, उसको मैंने बोला था उसको छूटेगा फिर। हम्म, हाँ हम्म, देखना, लगा के देखना, लगा के देखना 12:30। Okay, so question here explain why the composite function fg cannot be formed. Now why this composite function fg cannot be formed? Fg, if you see f of g, so you replace x with ax plus 1. Okay, so problems are of 1 mark, but you have to think a lot on all these. So here basically you have to look on the domains what is given. Why f of g cannot be formed? So let us go here on the top. The question f of g. Now see, if you are forming fg, then this g, okay, see here, g can take any value of real number, but for the function f, we restricted, okay, for the function f, we restricted the value of x. So therefore, f of g cannot be formed, okay. So I will say that we have defined gx such a way that it can take any value, any real number, okay, but for f of x, x can take only positive values. So therefore, f of gx cannot be formed. Gx would be negative also. So that gx negative value is not permissible over here. Okay. So yes, the problem was pretty logical. Okay. So why f of g is not formed? So f of g is not formed because the domain for f is all real number, whereas gx can take negative value as well. Gx can take negative value. So here I will say that your domain of f is greater than 0, but gx can take negative value as well. Therefore, I will say that fg cannot be formed. Thank you.